Hello, it's Isaacs, and welcome to another Showcase Devlog. This time, I'm showing off a game I have made a devlog on before that I've returned to and completed version 1 of the game. This is I just had this called like Untitled Game or Untitled Metroidvania on it before on my channel. You might recognize it a little bit if you ever watched that. But this, I've since titled the game and worked on it a bunch lately, and I've gotten to its current version 1 state. I make note of the version because this is a game I do intend in some capacity to return to and continue to update. But for now, I wanted to at least release the game in a very small, simple, but still complete enough form. And this video will be both showcasing the gameplay, and then me going into a little depth on how the game works. So with that, allow me to first show off the gameplay. I'm just going to do one run through. Here's our title screen. Game is Dunjon Krall, but spelled weird. Credits, because I don't, out of all my skills, audio is not one of them, so I still get those free things, but basically everything else you see is made by me. Here's the game. We're in now. So this is meant to be where you came out of, which is why you can't go back. You play as a knight who is currently not really named. Swing your sword. Swings up, swings down, depending on which way you're facing. Movement gets slowed down when you're doing that. You can go to a ladder, which lets you climb down. Find gold, increases your gold amount there. While you're on the ladder, you can only go up and down. You can turn sides, but you can't attack or anything. And skeleton. Attack them, they try to attack you back. Kill them and their bones rattle to the floor. So basically, that is like the gist of the gameplay loop. Now there's just different ways, so there's more gold scattered about. And there's more skeletons to kill. See, the darkness doesn't let you see very far, so then boom. They hurt. God. I could be playing a little bit better, but basically this is the gist of the game. Right now, or the main gist is just like traverse through the dungeon, go upstairs, downstairs. It's a potion for health. That's a little buggy. Anyway, go upstairs, downstairs, fight off the undead, manage your health, collect gold. Conceptually, very basic stuff. Making this game was not very basic. That's true for freaking any kind of game. But, I'm really happy with how this looks. It's not a lot. I do make art, but for one, pixel art is not my main forte, and animations aren't either, but as you can see, I'm trying. Oh god, did I get too much gold already? I have to fix this bar. Yeah, you can see the exit there. I have to increase the limit of the amount of gold it lets you have. Oop, alright, I fell all the way down. Okay. But yeah, the gameplay loop is very samey right now. There's obviously a lot more tweaks I could do to make things more engaging, but this is just version 1 of the game. I plan to do a lot more in the future, expanding things, adding a lot more to the gameplay. But here, we get to the ending, climb all the way up, and bosh. Triumph. Where you succeed. Windscreen tells you how much gold you got total. The guy does a little animation. Go back to the title, and I can show off the death screen. By getting killed by the skeleton very slowly. Show off the skeletons a little more, actually. So both you see the player and the skeletons have directional attacks. So, oh, I guess one thing I can show off. So you can see how the skeleton does chase me here. But if I go up this ladder, he's chasing me, he still sees me, but then he forgets. So the skeletons have a time to forget, basically, which I'll get into in a bit, about where once you're not right in front of them anymore, they'll eventually forget you and go back to their normal patrolling. But get their sights, die, defeat. Go straight back into the game or whatnot. But that is the gameplay. This is just the game, pretty much. Go through the dungeon, collect gold, fight skeletons, health potions to heal back up. Again, very simple premise, but now I'll go into how it was not so simple to make, at least for me. First things first, I suppose I can go into stuff like the objects, which are simpler. Like our gold pickup here. And I guess we can go into the components of that. So I have this little interaction component thing, where if you notice, this little icon pops up with all the things you're capable of interacting with in the game. So what the interaction component does is, if the player enters the hitbox I give the component, it will connect the player's to that object, essentially. So what it does is the player has an on-player interaction signal. When the interaction component of anything, the player goes inside of it. So player walks into range, that player's signal will hook up to this specific object it just did. So the player will connect to this. The player will connect to this specific object's interaction script. This one here. So if the player goes in, they connect to it. If the player leaves it, they disconnect to it. So this, imagine like this is like, signals working. There's now a tether between these two things. So they have an interaction script. Then we want to look at our actual object script. When here, what we do is our player interaction. So this method gets connected with this. So the interaction component is connected to the object we want. Once the interaction component is connected to the player, the component can then tell the object what happens when the player interacts with it. So basically, the signal gets connected to the player. The player then can click E to emit the signal. This then tells the object the player just interacted with it. So then the object on that player interaction, depending on which object it is, will execute its function. So if it's If the object type is a positive, it's a pick-upable object. If it's negative, it's a static kind of object. So if it's pick-upable on object picked up, omit its object type. And if it's not, activate the object. We'll look into activate in a second. But when the object is picked up, we then go to our game manager, where in here we have our on object pickup script. So if it's 1, that means it's gold, so it'll increase the amount of gold we have and play sound effect. If it's 2, it's a health potion, giving the player health and playing the sound effect. So, again, just to run through it one more time, we have an interaction component, which we can give a collision shape. If the player enters this area, it connects the player's signal to the interaction component's method here. So the player walks into the area of the object. The signal is then connected. Now, if the player presses E, or their interaction button, on the object, that interaction component will tell the object it's now hooked up to do its specific type. So whatever its assigned number is and what that number will do. So then the object itself, in this case our gold, in our object script, since its type is 1, set here in our export, omit to the game manager, that an object type of 1 has been picked up by the player. In that case, since it's gold, it'll then do that. So there's a lot going on there. It goes from the interaction component to the player to the object to the game manager, all just to give you some gold. But by doing it this way, it makes creating new objects really easy. Because technically, all I really have to do is, here in on-object pickup, I could just do something very simple where if the object type is equal to 3, do this. I do something with that, and then I just have to make a new scene, assign it to object type, and it basically just works. So that's the cool about making a system like this. Similarly is our object activation, which is how our ladders work. So this is this is a pick-upable object. Then here we have our ladder, which is an activatable object. So it's the same thing where we have an area the player could walk into to activate it. But in this case, if you notice in our object script, we have all this like ladder stuff. This is to make the ladder function, because the way it actually works in the game is a little weird. So the actual ladders themselves are sprites on the sprite sheet, meaning they're not actually objects. Only the hitboxes are the actual ladder object. And how they work is the ladders actually have 2 interaction components, where one of the components is at the top here, and the other, bottom and offset. When the game starts, I have it offset, so the second component moves to where I want the bottom of the ladder to be. So, this basically lets me set up vertical one-way ladders very easily, where I can just put as many sprites as I want, as high as I want, as you can see the thing here. Like this ladder component is, where is it? Yeah, this ladder, it's offset by like 760 pixels. So you see, I can make a really long ladder by just typing in there how far down I want the bottom of the ladder to be. But at that point, same thing. The player walks into it, they connect to that, but rather than it does the player interaction thing in our object script, because the ladders are -1, static, we'll see what happens. So if since it's -1, it's in the negatives, activate the object, and in that case, we emit that to our game manager. And on object activate, we have the object we have and its type. So since it's -1, that means it's a ladder. And in that case, we set up how the player can climb ladders. And I suppose we can circle back to that later, how the climbing ladders work. But that is essentially how all of our objects work. And if you notice, this is how stuff like our little win exit thing here is. Like, I could easily make, so this little win exit, so when you interact with this part of the thing, it'll basically end the game. What next? Probably we'll go into the player, but also both player and skeleton use this character class, where basically the player and the skeleton will also just be enemies, because I plan to have different enemy types in the future. They both share a lot of attributes, like what state they're in, on what surface they're on. They share animated sprites, attack hitboxes, movement speeds, and stuff. So both our player and our skeleton enemy share a lot of attributes. So we want to make a script that just holds both of that. So we can have the things all characters share, and we can have things that we want specifically for players and enemies. So for the player, or I guess we'll finish the character first. We have stuff like signals for when they take damage, flagging whether they're actually the player or not, because there's only going to be players and enemies. Which action state they're in, which means what action are they currently doing? Are they idle? Are they walking? Are they climbing, attacking, falling, landing? Landing I've not implemented yet, but it's here. And then which surface they're on, meaning are they on the ground? Are they in the air? Or are they on the stairs? The stairs is important to define because of the attack directions, which we'll get into. Bunch of variables. Health for them. This is taking damage, so they take an amount of damage. Manipulates the health. Omit that fact. If they're the player, play the player hurt. Skeleton, play the skeleton hurt. And if their health is less than 0, play this death animation. What the on-take damage omit does is just simply mainly for damage visuals. So if you noticed in the game, when something gets hurt, they kind of like get red and shake. That's what that is. I actually reused this out from the turn-based game I had worked on, which I have made a devlog on. I reused kind of that. And the whole having a character class thing, I reused that idea as well, because I realized it would really help for this game. Now then, similar stuff to that, where characters can take damage, they can gain health, and they can take attack actions, and then need to update those action states and surface states. Why update what surface state they're on and what action state they're doing. So, I guess we'll do the states and surfaces first. We'll do movement. Let's cover movement. So, basically, surface state, this used to work a lot differently, where I actually, this is actually still remnants in the game. Like, I had this whole, custom data layer surface type, and this method here where I'd use get surface type, and I'd use this to tell whether, I used to use this to tell whether the player was on the ground or stairs or not, but this was a really flawed system, and it's simply a lot more effective to tell which surface I'm on, dependent on just the collision normal of the player. Like, because there's just stuff built into the game it's like for character bodies that can be used to tell what kind of angle the player is standing at or whatever. Update surface state basically checks what the collision normal is. Like if we're on flat ground or we're on angled ground, it'll check that kind of surface type, and depending on which of those types is, so if we're on a flat surface, we're on the floor. If there's no surface beneath us, we're airborne. Otherwise, we're on stairs. And we have a little check to see if, when we're on the stairs, which is the last direction we went. So did we go up the stairs last, or down the stairs last? Because that's important to determine for which direction we make the sword swing go at. Because I do it this way because trying to do it based off of which way the character is facing is a little more buggy. So having it based on which way they actually moved is a lot more definitive. Then there's the action state. Skeletons can't climb, only the player can, so this just has that there. So if the player's climbing, boom, just update the state to that, return. Otherwise, if the current surface state is airborne, like we determined here, set their action to falling, and if they're not airborne, then check if they're attacking, walking, or idle, based on their movement and current animation. Boom! There's that. Then we have, I guess we look at still on movement, player movement. Very simple. Track stuff like movement direction, apply gravity if we're in the air and our falling animation as such. If we're not climbing a ladder, we have horizontal movement, that's basic, walking animation, idle animation, flipping the player if we're not attacking or landing, and if we're on a ladder, basically what just being on a ladder does is, if we're on the ladder, instead of doing horizontal movement, it locks us vertically. Now, the thing about that is one last thing I didn't mention about ladders. The ladders have a limit here that make it so that you can't just like... The way the ladders work, you're pretty much trapped in between the floor that the bottom of the ladder is at and the ladder limit at the top of it. And the ladder limit flips dependent on whether you're through it or not. So if you're at the top of the ladder, the limit will go beneath you, so it doesn't. Yeah, I can just show you. You see here, there's no floor here, but I'm still walking over what looks like air. That's because of the ladder limit, because I'm on it. But if I go on the ladder, it disappears because it moves, as you can see, it moves to the top. If the limit wasn't there, technically I could just go infinitely upward, but I can't. The ladders work a little weird. I'm probably gonna actually make it a real object in the future, because if you want to like have multiple stops on a ladder, I can't do that. There can only be 2 stops right now, so in the future that's something I could do. But for now, just explaining that. So yeah, that's that direction. We talked about the object direction. I suppose what we can talk about now are the attacks. So, as we said before, we want to determine, based off of the player's last motion on the stairs, which direction to set their swing at. So, like as in the player, in our HP player, we can check if we're standing attack, stairs up, stairs down, and the skeletons have the same thing, where they attack depending on which direction and whatever they're going. So in that case, we have our take attack action. So depending on the animation direction we set, depending on which surface we're on, set that current attack animation. If we're the player, we want to slow down our velocity while we're attacking. The skeletons do not slow down when they attack. It's just a little difference between them. And otherwise, there's the attack cooldown. So now we'll transition into talking about our hitbox component. Like the interaction component, it needs the collision shape attached to it. You see there. I can play the animation here for you. Bosh. It doesn't. It's just a little buggy when you're doing it this way, but when the hitbox component is the script for it, basically, it doesn't use signals. It does use methods, so that is something I could change, so it's not nearly so code dependent. But in this case, right now how it works is if the hitbox component hits a body that is a character, as long as if the body is the player and the parent isn't, this is basically okay. What this does is it basically just it's coded so that the player can't hurt themselves with their own hitbox. Otherwise, skeletons also are not capable of hurting other skeletons. But here, yeah. When the hitbox component hits whatever it's hitting, make that parent take the amount of attack damage attached to that current player. So as you can see, attack A damage and cooldown I have set up here. Eventually, I'm going to expand this to be a lot more easier to manipulate and such, but for right now, it's kind of more hard-coded. But yeah. It grabs the amount of attack A action damage the parent has and applies that to the character it hits. So then, and then plays the appropriate animation. There's not nearly as many hoops, like, for instance, it doesn't need to tell the game manager when a character hits another character. It doesn't need to tell them that. But what the game manager does track is the player's death. So if the player gets to 0 health or less, they play their death animations, they'll time out, and then the thing dies, like I showed at the beginning. Otherwise, that's about it for the player. Now I can get into the skeletons, or how the enemies work. So they have a lot more shit going on with them, in the way that they move. They're like enemy AI. So we can turn on our little hitboxes here to get a better look at how the enemies work. So like here, like, yeah, you can see my hitboxes. Go down the ladder. See this? You see the two ladder ends? There's one up the top and one at the bottom here. When you get to the skeleton, you can see they have a bunch of freaking raycasts. So this is the enemy sight line locking onto me right now. This is the limit to their sight. If I showed this before, but you go out of the sight line, they're still trying to chase me, still trying to attack me, but eventually he'll forget and move on. Yeah, it locks onto you as long as he still remembers you exist. Now the closer one is his attack range. If I get in there, he'll swing at me. But if I'm here, he'll still keep trying to chase me. And the one point at the bottom you see both have just checks whether you're in the ground or not. That's your surface checker. But yeah. Boom. Boom. And then they die and they just deactivated completely. But yeah, you see how the skeletons work there. So they're always going to chase me as long as I'm in their sightline. The sightline's going to kind of like track me a little bit. Here I can try to get 2 skeletons. They do run into each other, but they won't hurt each other. You can actually hit 2 at the same time. What a die. Showing off the death again. But yeah, basically, they have those 2 movement types, whether they're chasing the player or not. So, this is basic gravity, basic horizontal movement, chasing. So if they're chasing the player, then their direction they're facing is going to swap dependent on how the player's on the left or right. So the player's on the left, they'll be looking at them. This is determining that they're looking at them, so that the sightline raycast is always on the player. And here's the enemy patrolling movement. So basically what this does, how this works, is it tracks how many tiles that the enemy has walked over. So here's a good example. This skeleton has a travel limit of 6. So you can see the tiles on the. You see the tiles here. So we can well, it doesn't really help, but you can see the skeleton has a travel limit of 6. So they will be 1 tile, 2, 3, 4, 5, 6. So the enemy is going to basically, once they track that they have traveled 6 tiles, they're going to turn around and then go back. So it's going to keep pinging back and forth. So I'm going to travel 6 tiles. Once I have, reset the thing, turn around, and go back. So that's their like patrolling limit. They'll keep going back and forth depending on how many tiles they're allowed to travel. This is their little flip thing, and then they have your detect player. So as long as they aren't chasing the player, meaning the player has not entered their sightline detection, they're just going to keep patrolling. So as long as chasing player is true, they're going to keep patrolling, and their sightline is going to keep tracking on them. Now, the moment that the player is not in their sightline, their memory timer will begin to tick down. So they will forget about the player if they can't see them in 5 seconds. So while their sightline isn't on the player for 5 seconds, is chasing will get set to false, and they just go back to patrolling. Now, if they are chasing the player and they're within their attack range, they're gonna then set that to true, and then that'll allow them to actually attack, as you can see here. So if they're chasing the player's in range, and their attack is off cooldown, attack the player. Now, obviously, this means it's not like perfect for them, as we've shown that the skeletons can whiff, because then even then you're a little faster to move out of their range. But yeah, like the detection isn't perfect, as you can see, but I think its flaws are enough to make the enemies a little more interesting to fight, even for there only really being one kind of attack and whatnot. I'm still pretty proud of how it works. With that is pretty much all the interesting stuff. I mean, there's stuff like how the menus work, but that is just very basic. Screen, whatever, whatnot. And with that, I think I've really shown the extent of how the game works right now. I don't really need to. I guess I could explain like Game Manager a little more. I don't really need to, though. I mean, the only other stuff is like the UI and how that works. Like, what? Little fun bit like this coin bag will get bigger depending on how much gold you got in the end. Besides that, though, you know, gold bar, this shows how much gold you have, this shows how much health you have. And otherwise, for version 1 of the game, that's about it. One thing I will say, I really should have made devlogs while I was making all this stuff, because if you compare the game now to how it was in that first devlog, such a huge difference. But I just failed to make it during my process. I'm going to try to do better about that, but if you even watched this far to hear this, thank you. I hope this is understandable enough. I've had a lot of fun making this game. I really hope to see it grow a lot bigger. Again, it's very simple for now, but I have a lot of ideas and hopes for this game. I don't know where it's really going to end up, but I hope it's something that I can really update. This is the first game I really plan to have like an update path for. Besides that, I think that's it for this devlog. I need an outro. See ya.